In today's video, we will discuss the proofs of the properties of a parallelogram that we have discussed in our earlier class. Okay, there are 4 properties and today we will prove them. Now the first 2 properties are the opposite sides of a parallelogram are of equal length and the opposite angles of a parallelogram are of equal measure. So these 2 properties we will prove together. Okay, let's get started. Hello everyone, I am Payal and welcome back to my channel PDR Learning Point. If you are new to my channel, please do subscribe to my channel and hit the bell icon to get all the notifications. Number 1. The opposite sides of and the opposite angles of a parallelogram are of equal measure. Okay, so see here we have drawn a parallelogram. First we will name it. Say P, Q, R and S. So here we will write here PQRS is a parallelogram. Okay, now to prove this properties we will draw a diagonal in this parallelogram by joining the vertices Q and S. Okay. So that also we will write. Now we will write we have joined vertex Q and vertex S to get the diagonal QS. So we will write we have drawn diagonal QS. Okay, now this diagonal QS has divided this parallelogram PQRS in 2 parts, that is triangle PQS and triangle QRS. Okay, now what we have to prove? To prove that the opposite sides are equal, that means PS is equals to QR and PQ is equals to SR. And opposite angles are also equal, that is angle P is equals to angle R and angle Q is equals to angle S. Okay, now from triangle PQS and triangle QRS, what we will get? Okay, before that we will name the angles. Say 1, 2, this is 3 and this is 4. Okay, now from triangle PQS and QRS we will get angle 1 is equals to angle 3. Now how angle 1 is equals to angle 3? See, if we draw it separately, this is PS and it is QR and these 2 sides are parallel and QS is the transversal here, and that's why angle 1 and angle 4 are angle 1 and angle 3 are the alternate angles, so and they are equal. So the angle 1 is equals to angle 3. Similarly, we can write angle 2 is equals to angle 4. How? If we draw it separately, PQ and this is SR and QS is the transversal. Okay, so this is angle 4, this is angle 2. Again they are alternate angles, so here we will write down the reason why, because they are alternate angles. Okay, now in these two triangles QS is common side, so we will write QS is equals to QS because it is the common side. Okay, now from this what we will get? We will get this triangle PQS is congruent to triangle QRS according to which rule? ASA, congruency rule. Now if 2 triangles are congruent, that means their corresponding parts are equal. So from here we can write, therefore PS is equals to QR and PQ is equals to SR. PQ is equals to SR, and we can also write that corresponding parts means corresponding angles are also equal, that means angle P is equals to angle R. Angle P is equals to angle R. Now we have to show that angle Q is equals to angle S. But see, angle Q and angle S is not included between the triangle PQS and QRS. Now how to show that? Okay, we will do it here. Now see, angle Q can be written as angle 2 plus angle 3. Yes, this can be written as angle 2 plus angle 3. Now, angle 2 is equals to angle 4 that we have written here because they are alternate angles. Okay, and angle 1 is equals to angle 3. This also we have written here as their alternate angles. Now, in place of angle 2, we will write angle 4, and in place of angle 3, we will write angle 1. Now, angle 4 plus angle 1, if we add them, we will get this angle, that is angle S. Okay, so ultimately what we have got, that angle Q is equals to angle S. That means we have got that opposite sides are equal. PS is equals to QR and PQ is equals to SR, that we have already proved, and angle P is equals to angle R, that already we have taken out, and now we have shown that angle Q is equals to angle S. That means we have proved the property number 1, that is opposite sides and opposite angles of a parallelogram are of equal measure. Okay, hope you have understood this. 2. The adjacent angles in a parallelogram are supplementary. Okay, here we have to prove that the adjacent angle of the parallelogram is a supplementary, means the sum of the adjacent angles is equals to 180 degree. Okay, now here adjacent angles are angle P plus angle S equals to 180 degree, angle S plus angle R equals to 180 degree, angle R plus angle Q is equals to 180 degree, and angle Q plus angle P is also equals to 180 degree. Okay, now here we have get the set. Okay, but here we will prove for only one pair of supplementary adjacent angle. Okay, so if we prove this, then similarly we can say that this three also holds for the parallelogram. Okay, now we will focus on angle P and angle S. So first of all we have to write that here PQRS is a parallelogram. Okay, now PQRS, and now we have to prove that angle P plus angle S. To prove angle P plus angle S is equals to 180 degree. Now to do this, what we have to draw? We have to extend the lines. Okay. Okay. So these are the extended lines. See, after extended the line, what we have got? We have got here another angle, that is angle A. We will name it as angle A. Okay. We will write it down. We have extended the lines QP and PS. Okay. Now after extending, what we have got? We have got that angle A. Okay. Now we will name this angles also angle 1. This is angle 1 and this is angle 2. Okay. Now see, angle 1 plus angle A. If we add these two angles, we will get 180 degree. Yes, because they are forming a linear pair. Okay. So now angle 1 plus angle A equals to 180 degree. Okay. Again, see, PQ is parallel to SR. Okay. And PS is the transversal. That means angle A and angle 2 is equal. as their corresponding angles. Okay, see how this is PQ, this is SR, okay, and this is the transversal here. So this means this is angle A and this is angle 2. That means angle A is equals to angle 2. How? Because they are corresponding angles. Angle A is equals to angle 2 because corresponding angles. Okay. So now in equation 1, what we can do? What was the equation 1? First of all, angle 1 plus angle A equals to 180 degree. Okay. So in place of angle A, we can put angle 2 because angle A and angle 2 are equal. Okay, this is equals to 180 degree. So in place of angle 1 and angle 2, we can write it as angle P plus angle S is equals to 180 degree because we have just renamed angle P and angle we have renamed angle P and angle S as angle 1 and angle 2 to make it simple. Okay, so ultimately we have proved that the sum of the adjacent angles of a parallelogram is 180 degree, or the adjacent angles in a parallelogram are supplementary. Now similarly we can prove that angle S and angle angle S and angle R are supplementary, R and Q are supplementary, and Q and P is also supplementary. Similar process. Okay, so if we show only one, that is also enough. No need to show for all the angles. Okay, so hope you have understood this. This is very easy. Now move to property number 3. The diagonals of a parallelogram bisect each other. Okay, so for this also we will draw diagonals. First of all, we will name it, say A, B, C and D. Okay, so we will write here A, B, C, D is a parallelogram. Okay, now we will join because we need the diagonals. Vertex, or we will draw diagonal AC and BD. Okay, so let's join the vertices to draw them. Okay, and we will name the point of intersection as O. Okay, now what we have to prove? That we have to mention here to prove that they bisect each other. Bisect each other means what? If BD has bisected AC, that means that BD has divided AC into 2 equal parts. Okay, that means we have to prove that AO is equals to OC and bisected each other. That means if AC has bisected BD, that means AC has divided BD into 2 equal parts. That means BO is equals to OD. BO is equals to OD. Okay. Now, from the triangle AOD and triangle BOC, okay, we will name it 1, 2, 3, 4. Okay, now you will think why we have named only these 4 angles, because we are talking about triangle O or AOD, this triangle. So in this triangle we will consider these three angles only. Okay, so this is the common, so we will not take. So we are considering the corner angles and we have named it as 1 and 2. Similarly, in case of BOC also we have named this angle as 3 and 4. Okay, now we will start. From these two triangles, what we will get? We will get that angle 1 is equals to angle 4. Okay, angle 1 is equals to angle 4. Why angle 1 is equals to angle 4? Because see, AD is parallel to BC and AC is the transversal. That means angle 1 and angle 4 are alternate angles. Okay, very easy. Now similarly we can say that angle 2 is equals to angle 3. Angle 2 is equals to angle 3. Why? If you draw this AD and BC. So AD is parallel to BC and BD is the transversal, and these two angles are the alternate angles. Okay, and we know that alternate angles are equal. So what is the reason here? Alternate angles. Okay, now we have to find a side which is equal. That means AD is equals to BC. Why? Because just we have proved that the opposite sides of a parallelogram are equal. Opposite sides are equal in a parallelogram. Okay, so that means what we have got, that angle 1 is equals to angle 4, angle 2 is equals to angle 3 and AD is equals to BC. Okay, that means according to ASA property, we will get that triangle AOD and BOC are congruent. Therefore, triangle AOD and BOC are congruent. The AOD is congruent to triangle BOC. Which property? ASA. Congruent property. Okay, according to this, these two triangles are congruent. So, congruent means what? Their arcs are equal. Okay, so therefore we can write as, see, AO is equals to OC. AO equals to OC we can write. Okay, and BO or OB is equals to OD. Or we can write that BO is equals to OD. Okay, so ultimately we have proved that the diagonals bisect each other. Okay, so here is the proof. Okay, so we have proved all the properties of the parallelogram. Hope you have understood this. In our next video, we will start our next exercise, that is exercise I think 3.3. Okay, so until then, goodbye and have a good day. Thank you for watching my video.